Hey there everyone, Ramesh here back again with another video. In this video, I want to build CRUD REST API with Java, Spring Boot 4, Spring Data JPA, MySQL database. Well, Spring Boot 4 has released and we are going to explore how we can use Spring Boot 4 to build CRUD REST APIs. And we are going to use Spring Data JPA, which internally uses Hibernate to communicate with the database. And we are going to use MySQL database as a database. Okay, so we are going to implement this tutorial step by step. In a first step, we are going to create and set up Spring Boot project in IntelliJ IDEA. In second step, we will configure MySQL database in Spring Boot project. In third step, we will create a user JPA entity. In a fourth step, we will create a Spring Data JPA repository like user repository that will communicate with the database and handle all the database related logic. In fifth step, we will create user DTO and user mapper classes. So we use user DTO to transfer the data between client and server, and we use user mapper to map the entity to DTO and vice versa. In the sixth step, we will create user REST API. In next step, we will build get user by ID REST API, and then we'll build get all users REST API, and then we'll build update user REST API, and finally we'll build delete user REST API. Okay, so I'm going to basically create these 5 REST APIs using Spring Boot 4, which is the latest version of Spring Boot. Alright, so let us head over to the browser and let us create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA. So here I have opened Chrome browser, but you can use any browser that you want. In a new tab, just search for Spring Initializer and then hit enter. And here just click on the Spring Initializer link over here. Alright, and here you can see the project section. So here you can see different types of projects. We're going to create a Maven project. So let us keep Maven as selected over here. And then here we have different JVM languages like Java, Kotlin, Groovy. We're going to use Java. So let us keep Java as selected. And then Spring Boot version. So here Spring Boot is suggesting to use 3.5.6, but we are going to explore Spring Boot 4. So let us select 4.0.0 M3. Okay, don't select snapshot, just choose this one. And then go to the project metadata over here. So here let us give group com.springboot. You can give any group that you want, but make sure that the group is unique for your projects. And then artifact, let us give artifact name as Spring Boot user management. The artifact is same as the project name. Let us keep as it is. And then description, demo project for Spring Boot user management, and then package name com.springboot.user management. Next, packaging jar, and then Java version. Either you can use Java 25, 21, 17 as per your requirement. Next, go to the dependency section, and here let us search for Spring Data JPA. Well, we are going to connect our Spring Boot application with the MySQL database. For that, we are going to use Spring Data JPA, and Spring Data JPA internally uses Hibernate as a ORM framework. Just choose Spring Data JPA over here. Next, let us search for Spring Web Dependency. Well, we are going to use Spring Web Dependency to develop the RESTful web services. And the Spring Web Dependency internally provides Apache Tomcat as a default embedded container. Just select this Spring Web Dependency over here. And then here let us search for MySQL driver. In order to connect our Spring Boot application with the MySQL database, we have to use JDBC driver. In our case, we are going to use MySQL driver. Perfect. Next, go ahead and click on generate button to generate this project as a zip file. If you want to explore, you can just click on explore, and then here you can just see the details like version of the Spring Boot project and then the dependencies. Okay, just close it and then click on generate button, and here you can see Spring Boot application is downloaded as a zip file. Next, let us open this zip file in a folder and then extract this folder. Right click and then extract all. Select the location where you want to extract and then click on extract. Perfect, I have extracted in a downloads folder. Next, let us launch the IntelliJ IDEA and import the existing Spring Boot project. So in order to import the existing Spring Boot project, click on the open button over here and then go to the location where your Spring Boot application is present. In my case, it is in a downloads folder. and here just select this Spring Boot project and click on select folder, and then maximize this ID. Let us wait a couple of seconds because IntelliJ IDEA will automatically resolve all the Maven dependencies. Alright, now let us go through the project structure quickly. Here we have SRC folder. Within that we have a Java and then package, and this is the main entry point of our Spring Boot application. Next, within SRC folder you can see application.properties file. Here we can keep all the application level properties, and then here we have pom.xml file, and here you can see the Spring Boot version and then Java version 25. So here I'm going to use Java version 23 because I have already installed Java 23 in my machine. You can use Java 25 or you can use Java 21 as per your requirement. Let me give Java version 23 over here and then click on this sync my changes icon over here. Alright, perfect. Now we have successfully created and set up our Spring Boot 4 project in IntelliJ IDEA. In next lecture, we will configure MySQL database in our Spring Boot project. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will configure MySQL database in our Spring Boot application so that our Spring Boot application can communicate with MySQL database. So go to our project in IntelliJ IDEA over here and go to the application.properties file, and here let us configure the MySQL database related properties. So here just type spring.datasource.url. So this is a property we use to configure the JDBC URL to connect to the MySQL database. Next, let us type the JDBC URL over here, JDBC :MySQL :localhost. Well, our MySQL server is running on local machine, that's why I have given localhost over here. If your MySQL server is running on any other remote server, then you can specify the domain name or the IP address over here, and then followed by 3306 is the default port for MySQL server, and then followed by the database name. So let us give the database name as user_management. So here we have given a database name as user_management. So let us go ahead and create this database in our MySQL server. So just copy this database name and open the MySQL workbench over here, and here just type the SQL statement create database followed by the database name user_management. Next, select this statement and just execute it and refresh the schemas, and here you can see user_management database. Now we have created a user_management database. Next, let us go back to our project in IntelliJ IDEA over here. Next, let us configure the MySQL database username and password. For that, just type the property spring.datasource.username equal to root, and next let us configure the password as well. Just type the property spring.datasource.password. So here make sure to replace the MySQL database username and password as per your MySQL database installation on your machine. Next, let us configure one more property spring.jpa.hibernate.ddl-auto equal to update. Well, this property is pretty useful because this property tells Hibernate to automatically create the tables in a database as per the JPA entities that we create in our project. And if we do any changes in the JPA entities, then this property will update the database tables accordingly. Okay, so it will basically sync the JPA entities and their respective table columns. Next, let us configure one more property spring.jpa.show-SQL equal to true. Well, this property is also pretty useful because this property prints all the SQL queries that is generated by Hibernate. Okay, now we have configured MySQL database details in our Spring Boot application. Next, let us quickly run the Spring Boot application just to make sure that there are no errors while connecting our Spring Boot application with the MySQL database. So go to the main entry point class over here, and from here let us run the Spring Boot application. And notice here our Spring Boot application is up and running on embedded Tomcat server on port 8080. It means there are no errors in the console. You can see here. It means our Spring Boot application is successfully connected with MySQL database. And if you can see few details in the console logs over here. By default, Spring Boot uses Hikari data source. And here you can see database driver. Well, we don't have to configure the database driver class in our Spring Boot application. Spring Boot will automatically detect the database driver and it will configure accordingly. And again, we no need to configure the Hibernate dialect as well. Spring Boot will automatically, detect the dialect and it will automatically configure the Hibernate dialect as per the database that we use in our project. In next lecture, we will create a JPA entity. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a user JPA entity in our Spring Boot application. Well, before creating a user JPA entity, let us quickly create a standard packaging structure for our Spring Boot application. So here, go to the base package over here, right click on it, new, and then choose package. Let us give package name as entity. Within an entity package, we keep all the JPA entities. Next, let us create one more package and let us give name as DTO. Within a DTO package, we keep all the DTO classes. Well, we use DTO classes to transfer the data between client and server. Next, let us create one more package and let us give name as repository. Well, within a repository package, we keep all the Spring Data JPA repositories. Next, let us create a new package and let us give name as service. Within a service package, we keep all the service classes which holds the business logic. Next, let us create one more new package and let us call it as controller. Within a controller package, we keep all the Spring REST controllers. Next, let us create one more new package and let us call it as mapper. Well, within a mapper package, we keep all the mapper classes, and mapper classes basically holds the logic to map JPA entity into DTO and vice versa. Next, let us create one more new package and let us call it as exception. So within an exception package, we keep all the custom exceptions. Now we have created a standard packaging structure for our Spring Boot application. Next, let us go ahead and create a JPA entity. So go to the entity package over here, right click on it, new, and then choose Java class. And here let us give class name as user. And here let me expand this. Next, within a user class, let us go ahead and create the instance variables. So just type private and then long ID and then type private string first name, private string last name, private string email. To keep it simple, let us have these 4 fields in a user class. Next, let us go ahead and create a constructor and getter setter methods. Right click, generate constructor, select all these fields, click on OK. Now we have created a parameterized constructor for this user class. Next, let us also create a default constructor. So right click, generate constructor, and don't select any fields over here. Click on OK. Now we have created a default constructor or a no argument constructor for this user class. Next, let us also create a getter setter methods. So right click, generate getter setter, and select all these fields. Click on OK. Now we have created a user class. Let us make this user class as a JPA entity by using JPA annotations. So here, in order to mark this class as a JPA entity, let us annotate this class with @entity annotation. So make sure to import entity annotation from jakarta.persistence package. So this @entity annotation mark this class as a JPA entity which mapped with the database table. Next, let us use @table annotation to configure the table name for this user JPA entity. So here let us annotate this class with @table annotation from jakarta.persistence package, and this table annotation has name attribute, and here let us give the table name as users. Well, if you don't annotate this user class with @table annotation, then by default JPA will give the table name as class name. And typically we give the table naming convention like this That's why here we are using add table annotation to configure the table name for this user JPA entity. Next, let us annotate this ID field with add ID annotation to make this ID as a primary key for this JPA entity. And make sure to import ID annotation from jakarta.persistence package. Next, we need to configure the primary key generation strategy for this primary key. So in order to do that, we can use add generated value annotation from jakarta.persistence package. And this generated value annotation has strategy attribute. And here let us configure the value generation type identity. So this identity generation type will automatically create the primary key for this ID field. It means it internally uses database feature, that is auto increment, to automatically create and increment the value for the ID field. Okay, perfect. Next, let us annotate this first name field with add column annotation to map a column name with this field. And make sure to import column annotation from jakarta.persistence package. This column annotation has name attribute, and let us give column name as first underscore name. And apart from giving the column name, you can also specify the constants. For example, here let us type nullable false. It means this first name column does not allow the null values. If you give nullable equal to true, then this column basically allows the null values. Okay, so let us give nullable false. So by default the nullable is false, so let us remove this. Okay, and one more important point here is, if you don't annotate a field with add column annotation, then JPA is smart enough to map a default column name with this field, and the naming convention for default column name is first underscore name, like this, because here you can see this field contains two words, first and name. So by default JPA will give the column naming convention like this, first underscore name, if there are two words in the field. Okay, and this column name makes sense for this field, so we can also omit using add column annotation over here. If you want to specify the constants, then you can annotate a field with add column annotation. But here we are just mapping a column name with a field, so we can also ignore this column name annotation from here. Okay, next, same for last name field. We no need to annotate last name field with add column annotation, because JPA will automatically give the column name, that is last underscore name, for this field. So last underscore name makes sense. Next, go to the email field. So we have to make this email as a unique. For that, let us annotate this email field with add column annotation, and let us configure the constants unique true. So we are going to keep unique email IDs in the email column. That's why we have to configure the constants unique equal to true here. Okay, perfect. Now we have created user JPA entity. Next, let us go ahead and run our Spring Boot application, and let us confirm that Hibernate will automatically generate a users table for this entity in a database or not. So here, let us stop the existing running server and go ahead and start the Spring Boot application again from here. Well, look at here the console logs. Hibernate has created create table statement to create a users table in a database. And if you look at this SQL statement here to create the users table in a database. Okay. Next, let us confirm this users table in a MySQL workbench. So go to the MySQL workbench over here and refresh the schemas and expand this user underscore management database, expand user tables over here, and here you can see users table, select rows, and here you can see column names, ID, email, first name, last name. Well, notice the column name over here, first underscore name, last underscore name. So we haven't used at column annotation for first name and last name fields over here, but JPA has given the column name for these two fields like this. So this is the naming convention that JPA uses to give the column name, first underscore name, last underscore name. Okay, so this column name makes sense. That's why we haven't used add column annotation over here. Next, you can see here for email field we have annotated with add column annotation, and we have configured the column as a unique. So let us confirm this in the MySQL database. So go to MySQL workbench over here, go to users table, right click and click on this copy to clipboard, and click on this create statement over here. So we have copied the create statement SQL to the clipboard and just paste it over here. And here you can see unique key. So email is configured with unique key constant over here. Alright, it means that we have successfully created user JPA entity in our Spring Boot application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a Spring Data JPA repository for this user JPA entity. Well, Spring Data JPA simplifies a lot of boilerplate code that is required to develop the repository layer or the DAO layer. So let us go ahead and use Spring Data JPA in our Spring Boot project. So let us create a Spring Data JPA repository for this user JPA entity so that we can get the inbuilt CRUD operations for this user JPA entity. So go to the repository package over here, right click on it, new, and then choose Java class, and here select the interface and let us give the interface name as user repository and hit enter. Now we have created a user repository interface. Next, let us extend this user repository interface from JPA repository interface from org springframework.data.jpa.repository package. And this JPA repository is a generic interface and we have to pass the parameters. The first parameter is the type of the entity, in our case user JPA entity. Second parameter is type of the primary key, in our case long is the type of the primary key. For example, if you go to the user JPA entity over here, we have given long as a type for this ID field. So this long type we have passed over here as a second parameter to this JPA repository. Okay. Well, by extending JPA repository, user repository automatically inherits methods to perform database operations without writing SQL or implementation logic. Spring Data JPA will automatically create the implementation at a runtime. So some of the advantages of using JPA repository, like no boilerplate code required. So we no need to write the SQL queries or implement the methods manually. Automatic implementation. Spring Data JPA automatically creates an implementation of this repository at a runtime. We don't have to create a class that implements this user repository. Spring Data JPA will automatically create the implementation for this user repository at a runtime. Built-in pagination and sorting. So by extending this user repository, it gives the additional capabilities like sorting and pagination as well. Well, one more important point here is we no need to annotate this user repository with add repository annotation over here, because Spring Data JPA already annotated JPA repository implementation class with add repository annotation. For example, here go to the JPA repository source code. This JPA repository is an interface. It has an implementation class that is simple JPA repository. And notice here this simple JPA repository is already annotated with add repository annotation. Hence, we don't have to again annotate this user repository with add repository annotation. So just remove it. So this is the important. Okay. And again, by default, all the methods in all the public methods in a JPA repository are by default transactional. We don't have to use add transactional annotation in a service class methods. Okay. For example, if you go to simple JPA repository class again, you can see here this class is annotated with add transactional annotation, and at a public method levels also you can see add transactional annotation. It means all the public methods in a simple JPA repository are by default transactional, so we don't have to use add transactional annotation in a service class. Alright, so just remember these two important points. We no need to annotate a user repository with add repository annotation because Spring Data JPA already annotated this simple JPA repository with add repository annotation. And by default, all the public methods in a simple JPA repository are transactional, so we don't have to use add transactional annotation in a service class. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a DTO class and a mapper class to map entity into DTO and vice versa. So we are going to use a Java record feature to create the DTO class. Well, Java record is a special class in Java that holds a immutable data. And most of the time we create a DTO class to hold the immutable data and transfer that data between client and server, right? And this Java record is a good candidate for DTO. So in this project we are going to use Java record to create the DTO class. So here go to the DTO package in our application, right click on the DTO package, new and choose Java class, and here select record over here. Next, let us give the record name as user DTO and hit enter. Next, let us go ahead and define the fields within this class. So this is the record, so we have to pass the fields as a parameter to this user DTO. So here long ID and then string first name, string last name, string email. And again, the main purpose of Java record is that it significantly reduces the boilerplate code such as creating constructor, getter methods, toString, hash code equal methods. So here we no need to create the constructor, getters, equal, hash code and toString methods over here. Java compiler will automatically create a constructor for this user DTO record. Java compiler will also create a getter methods, hash code equals and toString methods as well. So in this way, the Java record basically reduce the significant boilerplate code. Next, let us create a mapper class to map JPA entity into DTO and vice versa. So here in our project we have user JPA entity and user DTO. So user DTO we use in a REST APIs to transfer the data between client and server, and we use user JPA entity to map with the database table. That's why we need a conversion between these two classes. So in order to keep the conversion logic, we will create a mapper. So mapper basically we use to map JPA entity into DTO and vice versa. Okay, so go to the mapper package over here, right click on it, new, and then choose Java class. So let us give class name as user mapper. Next, let us annotate this class with add component annotation from org.springframework.stereotype package. So this add component annotation mark this class as a Spring Bean, and Spring IOC container will automatically create the Spring Bean for this class because we have annotated this class with add component annotation. Next, within this class, let us create a method public, and then let us give return type as user DTO, method name to DTO, and then pass parameter as a user entity class. So here we are using toDTO method to convert user entity into user DTO. Alright. Next, within this method, let us have return statement and then new user DTO, and let us pass values to the constructor user dot get ID. Next, user dot get first name, user dot get last name, user dot get email. Perfect. Now we have written a code to convert user entity into user DTO. Similarly, let us create one more method that will convert user DTO to user entity. So here just type public and then give user JPA entity as a return type. Next, let us give method name as toEntity, and let us pass parameter to this method as user DTO. Perfect. Within this method, let us have a return statement and then new user JPA entity, and let us pass values to the constructor. So here user DTO dot ID, user DTO dot first name, user DTO dot last name, user DTO dot email. So these are the basically getter methods from user DTO. So user DTO is a record, and by default compiler will give the getter name as field name. You can see here ID, first name, last name, email. Okay. Now we have created toEntity method to map user DTO to user JPA entity. Okay, perfect. Now we have created a user mapper class to map user entity into DTO and DTO into user JPA entity. And again, notice here we have annotated this user mapper with add component annotation. So Spring IOC container will automatically create a Spring Bean for this class. Next, we can use add attword annotation to inject this user mapper Spring Bean in our project. Okay, perfect. So in this lecture, we have created user DTO as well as user mapper. Alright, great. In next lecture, we will create a REST APIs. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build create user REST API, and we will test create user REST API using Postman client. So here go to our project. So I want to first implement the service layer and then implement the controller layer, because the controller layer is depends on service layer, right? So go to the service package over here, right click on it, new, and then choose Java class, select interface, and here let us give interface name as user service. So within a user service interface, let us define a method. So here let us give return type of method as user DTO, and let us give method name as create user, and just pass user DTO as a parameter to this method. Alright, now we have defined create user method in a user service interface. Next, let us create a user service IMPL class that implements this user service interface and its create user method. So go to the service package over here. Within this package, let's create one more new package and let us call it as IMPL. So within the IMPL package, we keep all the implementation classes. So right click on IMPL package, new, and then choose Java class. Let us give a class name as user service IMPL. Next, this class implements user service interface. Next, mouse over on this user service class and just click on this implement methods. Select the method that you want to implement and just click on OK. Perfect. Next, let us make this user service class as a Spring Bean by annotating this class with add service annotation. So just annotate this class with add service annotation from org spring framework.stereotype annotation. So this add service annotation mark this user service IMPL class as a service component so that we can keep the business logic in the service class. And this add service annotation tells Spring Container to automatically create a Spring Bean for this user service IMPL class so that we can inject this Spring Bean by using add attribute annotation. Okay, perfect. Next, within this user service IMPL class, let us inject user repository. So here, just create a field private user repository. Well, we can also make this user repository as a final field over here. So once we make this user repository field as a final, we have to initialize this user repository using constructor. And once we assign it, we cannot change it later because this user field is final. Okay. Next, let us go ahead and use constructor based dependency injection to inject this user repository. So here just type public and then user service IMPL and then pass user repository and then this dot user repository equal to user repository. Now we have used constructor based dependency injection to inject this user repository. Well, here we can also annotate this constructor with at attribute annotation like this. But Spring 4.3 onwards, if the class has a single constructor, then we can omit using at attribute annotation. Alright, but if the class has a multiple constructors, then we have to annotate one of the constructor with at attribute annotation so that Spring Container can use that constructor to inject the dependency. Well, in our case, the user service IMPL class has a single constructor, so we can omit the at attribute annotation from here because Spring IOC Container will automatically inject this dependency using this constructor. Okay, perfect. Next, let us implement this create user method over here. So this create user method takes user DTO as a parameter. So let us convert this user DTO into user JPA entity first. So again, notice here we have a user mapper and we have made this user mapper as a Spring Bean by using add component annotation. So let us inject this user mapper in a user service IMPL and let us call its methods. So go to user service IMPL over here and here let us use constructor based dependency injection to inject the user mapper. So just type private and then final user mapper, and here we have already a constructor. So let us pass one more parameter to this constructor, user mapper, and here this dot user mapper equal to user mapper. Now we have injected user mapper using constructor based dependency injection. Next, go to the create user method and here let us call user mapper. It has two entity method and then pass user DTO. Next, this two entity method returns user JP entity. So here let us have a user JP entity object. Now we have a user JP entity object. Next, let us save this user JPA entity object into database by using user repository.save method. So here just call user repository, it has a save method, and then pass user JPA entity object. So this save method basically save the user JPA entity object into a database table, and this save method returns a saved user JPA entity object. So for that, here let us have a user and let us give the variable name saved user. Okay, so this save method basically return the saved user JPA entity object, and that we are storing in this saved user object. Next, let us convert this saved user object into user DTO. So here go to the return statement, just remove this null and then call user mapper. It has toDTO method and then pass this saved user. So here we are using toDTO method to convert this user JPA entity into user DTO. Alright, now we have implemented create user method to convert user DTO into user entity and save that user entity into database, and again convert that saved user entity into user DTO and just return that user DTO. Okay, next let us create a REST API that will internally call this create user method of this user service IMPL class. So here go to the controller package, right click on it, new, and then choose Java class. Let us give class name as user controller. Next, let us make this user controller as a Spring REST controller by annotating it with @REST controller annotation. Next, let us use @request mapping annotation to define the base URL for all the REST endpoints within this controller class. So here let us annotate this class with @request mapping annotation, and here let us specify the base URL /API/users. Alright, now we have used @request mapping annotation to define the base URL for all the REST endpoints within this user controller class. Next, within a user controller class, let us inject user service dependency, and again we are going to use the constructor based dependency injection to inject the dependency. So here just create the field first, private final user service. Well, notice here we are injecting the dependency using user service interface. So this is not a class, that is user service IMPL class. We are using user service interface to inject the dependency. Well, Spring team recommend to use interfaces to inject the dependencies, because injecting interface as a dependency gives a lot of advantages, like you can swap the implementations of interface, and also you can mock the implementation whenever you write the unit testing. Now we have made this user service field as a final, so we have to initialize this user service in a constructor. So let us use constructor based dependency injection to inject this user service. So just right click, generate constructor, select the field, click on OK. And again we don't have to use @avoid annotation to inject the dependency, because this class has a single constructor. So Spring IOC container will automatically inject the dependency by using this single constructor. If you have multiple constructors within this class, then you have to annotate one of the constructor with @avoid annotation, so that Spring IOC container will inject the dependency by using that constructor. But in our case we have only one constructor, so we can omit using @avoid annotation over here. Okay, perfect. Next, let us go ahead and build create user REST API. So here let me write the comment, build create user REST API. Well, creating a REST APIs with Spring Boot is very simple. We just have to create a method and we can make that method as a REST API by using Spring annotations. Alright, so here just type public. Let us give return type as response entity. Well, we are going to use response entity class from org springframework.html package to create the complete response for the REST API. So this response entity is a generic. So let us pass user DTO as a type to this generic class, and let us give a method name as create user. Next, let us pass user DTO as a parameter to this method. Within a create user method, let us call user service. It has create user method and then pass user DTO object. Perfect. Next, this create user method returns a saved user object in a user DTO. So here let us introduce a local variable of type user DTO and let us call it as saved user. Okay, next let us have a return statement, and then here you can see create user has a return type response entity. So here just type response entity. So response entity has a OK method. So this OK is a static method and it returns a HTTP status 200 OK. So here just call OK method, and look at here, there are two overloaded OK methods, and we have to use the OK method that takes content in the body. So just call this OK method that takes saved user object in the body. Now we have created a create user method. Next let us make this method as a REST API by using Spring annotations. And notice here this create user method basically create a new user object, that is save the new user object into database. That's why we can make this method as a post REST API. So here let us annotate this method with add post mapping annotation. So we use add post mapping annotation to map HTTP post request to this method. Next, the post request basically contains a JSON object, and we need to bind that JSON object into this Java object. So in order to do that, we can use add request body annotation. That's it. We have successfully built create user REST API. Next, let us go ahead and use Postman client to test this create user REST API. So here, stop the server and start the server again. And notice here our Spring Boot application is up and running and an embedded Tomcat server on port 8080. Next, let us open the Postman client over here, and here let us create a new request, and here let us choose HTTP post method. Let us enter the URL HTTP localhost 8080/API/users. Well, if you go to the project again and if you go to the user controller, so this is the base URL for this create user REST API, right? So this is the URL we are specifying in the Postman client over here. Okay, next this is the post request, so we have to pass a JSON in the body. So go to body, go to raw, choose content type JSON over here, and within a body let us create a JSON. So here just type ID. So we don't have to give the ID because Hibernate will automatically create the primary key. So here just give first name, let us say Ramesh, last name, so let us say Kadtari. You can give any values for these fields. Next, email ramesh@gmail.com. Perfect. Now we have a JSON object in the body. Next, go ahead and click on send button to send the request, and there we go. You can see the response over here, ID1, first name, last name, email. It means the create user REST API is working as expected. Next, let us confirm this user is saved into database or not. So just go to the MySQL workbench over here and go to the users table, right click, select rows, and you can see here Ramesh user is saved into users table. It means the create user REST API is working as expected. Next, let us go back to the Postman client and let us insert one more user, first name Ram, last name Jadhav, ram@gmail.com. Click on send button and look at here the response, ID2, first name, last name, email. So let us confirm this. Go to the MySQL workbench, select rows from users table, and you can see here Ram user is also inserted into users table. Well, notice here we did a small mistake over here. So this create user REST API is returning HTTP status 200 OK, but ideally the create REST API should return the HTTP status 201 created. Okay, so this create user REST API basically create a new user and save in the database. That's why this REST API have to return the HTTP status 201 created. So let us change this REST API and return the status 201 created. So let us head over to the IntelliJ IDEA and here go to the create user REST API, and here you can see the REST API returns the HTTP status 200 OK. Now let us change it. So here response entity dot status and then HTTP status. So you can see here HTTP status is a enum, so just import it. It has a created, so just call this created, and then next pass this saved user object in the body. For that just call body method over here and then pass saved user. That's it. Now this create user HTTP returns the HTTP status 201 created. If you go inside this created status, you can see status 201. Okay. Next, let us stop and run the Spring Boot application and let us quickly test this. Well, our Spring Boot application is up and running. Next, let us go to the Postman client over here, and here let us give first name Pramod, last name Pawar, and then email pawar@gmail.com. Click on send button, and there we go. You can see the status over here, 201 created. This is correct status. Okay. So whenever you create REST API, then make sure that the create REST API should return a 201 status, because the create REST API basically create a new resource at a server side. Alright, now we have successfully built create user REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get user by ID REST API, and we are going to test this REST API using Postman client. So let us head over to our project in IntelliJ IDEA over here. So first we're going to implement the service layer, and then we'll implement the controller layer, because the controller layer is depends on service layer, right? So go to the service package over here. Within that we have a user service interface. Within a user service interface, let us define a get user by ID method. So here let us give return type of the method as user DTO, and let us give method name as get user by ID, and let us pass long ID as a parameter to the method. Now we have declared get user by ID method in a user service. Next, let us implement this method in a user service MySQL class. So just click on this icon to navigate to the user service MySQL class, and here just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Now we got get user by ID method over here. Next, let us implement this method. So before implementing this method, let us create one custom exception, that is resource not found exception. Well, if user with a given ID is not exist in database, then we'll throw resource not found exception with a custom error message. For that we need a custom exception, right? Alright, so let us create a custom exception. So go to the exception package, right click on it, new, and then choose Java class. Let us give class name as resource not found exception. Next, this class extends a runtime exception. Next, within this class, let us create a constructor public resource not found exception, and then pass string message as a parameter. Next, within this constructor, let us call super keyword over here to just pass this message field to the super class constructor. So here we use super to call the super class constructor and pass this message. Now we have created resource not found exception. Next, let us go back to user service MySQL class over here. Go to get user by ID method. Within this get user by ID method, let us call user repository. It has find by ID method, and notice here find by ID method returns optional of type user. So just call find by ID method over here to get the user by ID and just pass the ID. Next, find by ID method returns optional. So here we can call or else throw method over here. So we use or else throw method to throw the exception if a user with a given ID is not existing in database. And notice here or else throw method takes supplier as a functional interface, and we have to use the lambda expression to implement this supplier functional interface. So let us call or else throw method over here and then pass the lambda expression. So this is the lambda syntax, followed by just throw resource not found exception over here, and then pass the custom exception message user not found with ID, and then pass ID over here. Alright, next let me align this properly. Alright, and here let us take the result of this method into local variable of type user. Let us call it as user. Now we have written a code to get the user by ID, and if a user with a given ID is not exist, then we throw resource not found exception like this. Okay, perfect. So now we got the user JPA entity. Next, let us convert this user JPA entity object into user DTO. So here, go to the return statement, just remove this null and then call user mapper. It has two DTO method and then pass user object. Perfect. Now we have created get user by ID method to retrieve the user by ID. Next, let us build the REST API that will internally call this method. Go to the user controller over here, and here let us build get user REST API. So just type public. Let us give a return type as response entity. Response entity is a generic class. So let us pass user DTO as a type, and let us give method name as get user by ID, and then pass ID as a parameter to this method. And within this method, let us call user service. It has get user by ID method and then pass ID. So this get user by ID returns user DTO. So let us introduce a local variable of type user DTO here. Next, let us have a return statement, and look at here, this get user by ID method returns response entity. So here just call response entity, and then it has a OK method and then pass user DTO in the body. Now we have created a get user by ID method that returns a user by ID. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @getMapping annotation. Well, we use @getMapping annotation to handle HTTP GET request. Next, let us pass ID to this getMapping annotation. So here within a double quote slash within a curly braces, just pass ID. So this ID is basically a template variable, and we have to bind the value of this template variable to this method argument. So in order to do that, we can use add path variable annotation over here. Well, notice here the method argument field name ID and the template URI variable name ID. So both are same, so we don't have to manually specify the name within a path variable annotation. But if the method argument name is different, for example, let us say user ID, then here we have to specify the URI template variable name over here. For example, ID like this. Then only add path variable annotation will map the value of this URI template variable to this method argument. Okay, so here let me undo it. So just keep both the variable names same so that there will not be any confusion. Now we have built get user by ID REST API. Next, let us run the Spring Boot application and let us test this REST API using Postman client. So here let me stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us head over to the Postman client over here, and here let's create a new request, and let us keep the HTTP GET method over here, and here let us enter the URL localhost 8080/API/users. Next, let us say we want to fetch the user with ID 1, then we can specify the ID in the URL. So if you go to MySQL workbench and go to the users table over here, here you can see Ramesh is the user who has ID 1. So if you want to fetch the user Ramesh, you have to specify the ID 1 in the URL. So go back to the Postman client, and here let's specify the ID 1 over here. Next, click on send button, and there we go. In a response, you can see the user details who has the ID 1. So this is how we can fetch the user object by ID by using this REST API. Next, let us say you want to get the user with ID 2, then you can just specify the user ID 2 in the URL, click on send button, and there we go. You can see the user with ID 2 details over here. Next, let us test the different scenario, like if user with a given ID is not existing in database, then the REST API have to throw the resource not found exception and send the default error response back to the client, right? So here let us say we pass the user with a ID 3. So user with ID 3 is not existing in database. So let us send the request and let us see how the REST API will give the response. And look at here the response, status 500 error, internal server error. So ideally the REST API should return the status 404, but you can see the status 500 over here. So let us quickly change the REST API so that the REST API can return the status 404 whenever the resource, that is user with the given ID, is not existing in database. So let us go to the project, and here let us stop the server, go to resource not found exception, and here let us annotate this exception with at response status annotation, and just specify the HTTP status not found. Okay, next let us run the Spring Boot application again. Well, our Spring Boot application is up and running. Next, let us go to the Postman client. Now let us call this REST API again, and notice here we have specified the user ID 3, which is not existing in database. Click on send button, and now you can see the response over here, status 404, error not found. Now the response looks good, isn't it? So this is how we can create the custom exception, and we can annotate with at response status annotation with the status code. Now we have tested both positive and negative use cases. It means the get user by REST API is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get all users REST API, and we will test this REST API using Postman client. So let us go to our project in IntelliJ IDE over here, and here let us first stop the server over here. Next, let us implement the service layer first, and then we'll implement the controller layer, because the controller layer is depends on service layer, isn't it? So go to the user service interface over here, and within a user service interface, let us declare a method. So here let us give return type of the method as a list of type user DTO. Let us give method name as get all users. Next, let us go ahead and implement this get all users method in user service IMPL class. So just click on this icon, it will head over to user service IMPL class. Just mouse over in this class, click on implement methods, select the method that you want to implement, click on OK. Now go to the get all users method over here, and here let us implement this method. Within this method, let us call user repository. It has find all method. So notice here there are overloaded find all methods, and we have to choose the appropriate one. So in our case, we are going to choose the find all method that doesn't take any parameter. And notice here find all method returns a list of type user. So just call this find all method over here. As this find all method returns a list of user, so just take the result into local variable of type list as a generic. So just pass user as a type, and then call it as users. Perfect. Next, we need to convert this list of user JPA entities into list of user DTOs, because this get all users method returns list of user DTOs, right? So here, in order to convert this, we can use the stream. So list has a stream. So here just call users. Users is a list, it has a stream method. So just call stream method. Stream has a map method. So let us call this map method to map user JPA entity into user DTO. Next, in order to map, we can use user mapper class. It has to DTO method. That's it. So here we are using method reference to call to DTO method over here, and this internally will basically convert each user entity object into user DTO. And finally, we need to collect the result. For that, just call toList method over here, and notice here toList method returns a list of user DTO. That's it. Next, let us remove this return statement, and here just put the return statement. Perfect. Now we have implemented get all users method that returns a list of user DTOs. Next, let us build the REST API that will internally call this method. So go to the user controller, and here let me first write the comment build get all users REST API. So just type public, let us give response entity as a type. Response entity is generic, so let us pass type list. Again, list is generic, let us pass a type user DTO. Next, let us give method name as get all users. within this method, let us call user service. It has get all users method. Get all users method returns a list of user DTOs. Let us call it as users. Next, let us have a return statement over here, and then response entity. It has a OK method, and just pass users in the body of the OK method. Perfect. Next, let us make this method as a REST API by annotating this method with @getMapping annotation. This getMapping annotation basically handles HTTP GET request. Perfect. Now we have built get all users REST API. Next, let us run the Spring Boot application and let us test this REST API using Postman client. So here, let me start the Spring Boot application. Well, notice here, the Spring Boot application is running on embedded Tomcat server on port 8080. Next, let us go to the Postman client over here, and here let us create a new request and choose HTTP GET method and just enter the URL localhost 8080/API/users. Alright. Next, if you go to the MySQL workbench over here, within a users table, we have two users, right? So let us go back to Postman client and just click on send button, and in a response you can see a list of users. So there are two users. So as you can see in a users table in a database, two users, and in a response you can see there are two users. It means the get all users REST API is working as expected. Okay, great. In next lecture we will build update user REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build update user REST API and we will test this REST API using Postman client. So let us head over to our project in IntelliJ IDEA over here. First, we're going to implement the service layer and then we'll implement the controller layer, because the controller layer depends on service layer. So go to user service interface over here, and here let us declare a method. So let us give the return type of the method as user DTO, and let us give method name as update user, and let us pass parameters to the method long ID. This is the user ID, and then user DTO. So this user DTO basically holds the updated user details. Now we have created update user method in user service interface. Next, let us provide the implementation for this method in a user service IMPL class. So go to user service IMPL class, just mouse over on this class and click on implement methods and click on OK. Next, go to update user method over here and let us provide the implementation. So here within this method, let us first get the user object by ID from the database, and if the user with a given ID is not existing in database, then we have to throw the resource not found exception, isn't it? So we have already written that logic in get user by ID method over here. You can see here, and you can see here we are calling user repository dot find by ID method. If the user with a given ID is not existing in database, then we throw the resource not found exception over here by using this or else throw method. If the user with a given ID is existing in database, then this method returns a user JPA entity object over here. Okay, so just copy this piece of code and go to the update user method over here and just paste it. Okay, now we got the user JPA entity object from a database. Next, let us update this user JPA entity object and let us save into database again. Okay, so here user JPA entity object, it has set first name method, so we can get the updated details from this user DTO, right? So here user DTO dot first name, next user entity object dot set last name, and then user DTO dot last name, user dot set email, user DTO dot email. Okay, so basically here we are just setting the data from user DTO into user JPA entity. Now we have updated first name last name email into user JPA entity object. Next, let us save this user JPA entity into database table. So for that, let us call user repository. It has a save method and then pass user JPA entity object. Well, this save method basically performs two operations. First is like if the user entity object don't have ID, then it will perform the insert operation. If the user entity object has ID, then it will perform the update operation. Okay, so in this case the user entity object has ID, so it will perform the update operation. Okay, and again the save method returns the updated user object. So here let us take that object into local variable of type user, and let us give variable name as updated user. Perfect. Next, let us convert this updated user JPA entity object into user DTO, because this update user returns user DTO, right? So here just remove this null and just call user mapper. It has toDTO method and then pass updated user object. Perfect. Now we have implemented update user method to update the user details into a database. Next, let us build the update user REST API that will internally call this update user method. So go to update controller over here. Within that, let us build the update user REST API. So here let me write the comment build update user REST API. So here let us create a method public. Let us give return type as response entity. Response entity class is a generic, so let us pass type as a user DTO. Next, let us give method name as update user, and let us pass parameters to the method over here, long ID and then user DTO. So this user DTO holds the updated user details. Next, within this method, let us call user service. It has update user method and then pass ID and then user DTO. Next, this update user method returns updated user object. So here let us introduce a local variable of type user DTO, and let us give the variable name as updated user. Perfect. Next, let us have a return statement over here and then call response entity. It has a OK method and then pass updated user. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @put mapping annotation. So this put mapping annotation will basically map the incoming HTTP put request to this method. Next, let us pass the ID, that is URI template variable. Next, in order to bind the value of this URI template variable to this method argument, we have to use @path variable annotation over here. Next, in order to bind the JSON from the request into this J object, we have to use @requestBody annotation. Okay, perfect. Next, let me maximize this. Now we have built update user REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, I'm going to stop and rerun the Spring Boot application. You'll notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us head over to the Postman client over here, and here let's create a new request, and here let us choose HTTP put method over here, and let us enter the URL localhost 8080/API/users, and let us pass the user ID that we want to update. For example, let us say we want to update the user with ID 1, then pass user ID 1 in the URL like this. Next, go to the body, and here go to the raw, choose content type JSON. So here in a request we need to pass the JSON that contains the updated user details. So here let us create a JSON. So let me maximize this. Let us say first name. So if you go to MySQL workbench over here, and here go to the users table, and you can see user with ID 1. So first name is Ramesh, last name Padtare, and this is the email. Now let us say we want to update the first name, last name, email, these three fields. Then that information we can put in this JSON over here. So first name, let us update from Ramesh to Umesh. Last name, let us change from Padtare to Pawar. And then email, let us change from ramesh@gmail.com to umesh@gmail.com. That's it. Next, let us send the request and let us see how this REST API works. So go ahead and click on send button, and there we go. In a response you can see the user with ID 1. The first name is updated, last name is updated, email also updated. If you want to verify this, go to the MySQL workbench and just select rows from users table, and here you can see the user with ID 1. The first name is changed from Ramesh to Umesh, last name and email as well. So this is how we can use update user REST API to update the particular user. Next, let us test the other use case, like if user with a given ID is not existing in database, then this update user REST API have to return the error response with the status 404, right? So here let us pass the user ID 3. So user with ID 3 is not existing in database, isn't it? So click on send button, and there we go. You can see the response, the error response, status 404, error not found. It means the update user REST API is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build delete user REST API, and we will test this REST API using Postman client. So let us head over to our project in IntelliJ over here, and here let us stop the server first. Well, first we're going to implement the service layer, and then we'll implement the controller layer, because the controller layer is depends on service layer. So go to user service interface, and here let us declare a method. Let us give a return type of the method as a void, and let us give method name as delete user, and let us pass a parameter that is user ID, long ID. Perfect. Next, let us implement this method in a user service IMPL class. So go to user service IMPL class, just mouse over on this class, click on implement methods, click on OK, and go to delete user method over here, and let us provide the implementation. So within this delete user method, let us write a logic to check if a user with a given ID is existing in database or not. If a user with a given ID is not existing in database, then we'll throw the resource not found exception. Well, if you go to update user method over here, so here we have already written that logic. So let us copy this line of code and go to delete user over here, and here just paste it. Okay, so here we are just checking like if a user with a given ID is existing in database or not. If a user with a given ID is not existing in database, then we simply throw the resource not found exception with a custom error message. Next, if a user with a given ID is existing in database, then this find by ID method returns a user object. Next, we can delete this user object from the database. So for that, just call user repository. It has a delete method, and then pass user. So you can also use one more delete method, that is user repository dot delete by ID method. So both will do the same. So you can use either delete method or delete by ID method. So let us say we use delete method over here. Okay, now we have implemented delete user method to delete a particular user. Next, let us build delete user REST API that will internally call this delete user method of user service IMPL class. So go to the user controller over here and go at the end, and here let me write the comment build delete user REST API. So just type public and then response entity. Next, let us pass string as a type. So this delete user REST API basically returns the success message. For that, we can pass string as a type to this response entity over here, and let us give the method name as delete user, and let us pass parameter to this method, that is long ID. Next, within this method, let us have a return statement, and then response entity, and then call OK method, and then here just pass the success message user deleted successfully. Okay, perfect. Next, let us annotate this method with @delete mapping annotation, and then pass the ID / within a curly braces ID. Next, in order to bind the value of this URI template variable to method argument, we use @path variable annotation. Well, notice here within this delete user method, we haven't called the user service delete user method. So here just call user service, it has delete user method, and then pass ID. Now this delete user method will delete the user object by this ID. Okay, perfect. And one more important to note here is that some of the developers don't return any response for this delete REST API. But here we are simply returning the success message to the client. Now we have built the delete user REST API. Next, let us run the Spring Boot application and let us test this REST API. So from here, I am going to run the Spring Boot application. Our Spring Boot application is up and running and an embedded automated server on port 8080. Next, let us head over to the Postman client over here, and here let us create a new request, and here let us choose HTTP delete method and just enter the URL localhost 800/API/users, and here let's specify the user ID that we want to delete. Let us say we want to delete a user with ID 1, so let us specify ID 1 over here. Next, click on send button, and there we go. You can see the response, user deleted successfully. And if you want to confirm this, go to MySQL Workbench and here select rows from users table, and you can see here the user with ID 1 is successfully deleted. Next, go to the Postman client, and next let us pass user ID 2 over here and just click on send button, and notice here user deleted successfully, and just confirm from database, and there we go. You can see user with ID 2 is successfully deleted. Next, let us verify the other use case, like if a user with a given ID is not existing in database, then the REST API have to return the error response with the status 404, right? So here just pass the user ID 3, click on send button, and notice here the error response status 404 not found. It means the delete REST API is working as expected. Alright, great. I will see you in the next lecture.